So the purpose of this video is to demonstrate some ideas that are connected to these notes you should have taken. Before you would start watching these videos, you would want to make sure to have a basic definition of series and parallel, both with batteries and also with resistors. There's some equations associated with it, and then a definition of combination. This document would be shared with you. But to start and just show a FET simulation, this would be an example of batteries in series. Notice that the electrons are flowing from negative around to positive. Always remember the direction of current flows from negative to positive. You'll notice the batteries here are connected in series. That means the voltages are getting added up. So if these were each 1 volt, 1.5 volts, this would be a 4.5 volt system right here. Notice how bright the light is. Likewise, if we connected batteries in parallel, you'll notice that the electrons in this case are going again from negative around through to positive. And in this case, these three batteries are all in parallel. So if every one of them was 1.5 volts, the total voltage from here across to here would be 1.5 volts. That's actually demonstrated by the fact that we see slower movement, less current. Of course, the current, if you notice here, it divides and goes three ways. So it's really slow through each one of these. And we see the light isn't really that bright. The reason why this current would be slower compared to here is here you have more voltage, there's more push, more is pushing that. In this case, one major difference here, these batteries would last longer, so this light would stay on a lot longer than this light. As you can kind of imagine, it's really bright, the energy is being used up. Each battery has the same amount of energy if all other things are equal, but if they're connected in parallel, the battery's energy would be used up more slowly. If we move on to lights or resistors, and it's worth noting that a resistor and a light are effectively can act the same way. Now they can have different values, but a light and a resistor can, and any device, a fan, a motor, anything that's using electricity is basically a type of resistor. This would be an example of a parallel circuit, and you'll notice the current here is again going from negative around to positive. And notice in a parallel circuit, the electrons have options. They have different ways they can go, but they definitely go through one part of it, and then they all come back together here. We can contrast this with resistors connected in series. Here, an electron has to go through each and every one. And you notice how slow the current here is, because resistance adds up when resistors are in series. Compare how slow that current's going to the current right through here. See how fast it's going. We still have 3 resistors. I can actually get rid of this and put a light on it just in case you think the resistor is affecting that. It's definitely not. And it actually makes sense if you think about it. Imagine these are cash registers and you have a bunch of people in line here. If the line can split 3 ways and go through those 3 different cash registers, as opposed to if the line, everybody has to go through each cash register and then to the next one, you can see where there would be more resistance to this flow of electricity. The final thing to point out would be a combination circuit. This would be a nice example of a combination circuit. Here we have 2 lights or 2 resistors in parallel, and then they are connected in series with this other one. And so hopefully that helps. Thank you. I hope you have a great day.